So, welcome everybody again. This is Ayyappa Srinivasan of St. Martha's Engineering College, Assistant Professor Triple Department. So, in this video, we are going to see about resistors in series and parallel. A simple way to remember this concept is whenever two or more resistors are connected in series. Only one thing I will say, whenever two or more resistors are connected in series, the equivalent resistance is sum of their resistance. That is, if R1 and R2 are connected in series, then equivalent value is sum of their resistance. Then, if again resistors are in parallel, right, more than one resistors are in parallel, then their equivalent value is that as found as follows: 1 by R inverse. The 1 by R is nothing but 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Now, the students are usually confronting with a confusing in their mind that how to find whether resistance are in series or in parallel. The only way is to analyze whether same current flows through them or not. Right? For example, now if you take this one, there you can find that the current starts from voltage source, then it flows through R1, R2 and returns. So, same current flows through it. So, whenever in two resistors, same current flows through, they are said to be in series. Now, take this figure. If you analyze this, then you can find again that current starts from this into mark point and it is divided in R1, R2, R3, R4. So 4 points it is divided. That is, so different currents flow through them: R1, R2, R3, R4. So as different current flows through them, they are in parallel. So for parallel, 1 by R is equal to equivalent resistance is 1 by R inverse, where 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and it goes like that. So kindly consider this point. Then we will see some problems. So now we have another thing called voltage division as current division rule. So in two resistance, if current flows, the current through each and every resistance is given by the following formula. So current through a resistor is given R1, this is R2. So total current be I. Then current through R1 will be given by IR2 by R1 plus R2. And current through R2 will be given by IR1 by R1 plus R2. So we have to find, we have been given with a problem in this way. Find the current through each resistor. So 3 ampere, right? 3 ampere is flowing through 2 ohm and 3 ohm. So 3 ampere is find the current through each of them. So now to find current through 2 ohm, it is R1 and it is R2. IR2, 3 into 3, 9 by R1 plus R2, 2 plus 3, 5. 9 by 5, 1.8 ampere. Then current through 3 ohms is given by 3 ohms is R2. So IR1, 3 into 2, 6 by 2 plus 3, 5. 6 by 5, 0.2 ampere. So if you add, 6 into 0.2, 1.2. So if you add, you can find the equivalent current again 3 ampere in total. Now let us consider another example. Find the equivalent resistance across the terminals A and B. Right? Let us consider another problem. So here comes whether the resistance is series or parallel. Whenever while solving such a problems, kindly keep in your mind that you may be asked to find resistance across particular terminal. Then you have to reduce from other end. For example, we have been asked to find the resistance across A and B. Then you have to reduce the resistance from the other end, that is from this end, that is 15 ohm end. So kindly keep this in your mind. So now we have to reduce from 15 ohm end. So we have to consider 20 and 15. 20 and 15, how are they? Same current flows through them, right? 20 through 20 and 15, same current flows through them. So they are in series. So we have to add 20 plus 15, 35 ohm. Now, in the next one, 35 and 5 we have to consider. But the current flowing through them is different, so they are in parallel. So, we have to use the formula R equivalent is equal to R1 R2 by R1 plus R2. R1 R2. So, R1 into R2, 35 into 5, 175 by R1 plus R2, 35 plus 5, 40. The answer is 4.375 ohm. This is what? The reduction of 35 and 5. So, we have reduced this in this way. Now, consider 25, 10, 4.375. If you see, same, if a voltage source is connected across this terminal, then through 25, 10, 4.375, same current will be flowing through them. So, we have to add, which will give 39.375 ohm. This is the answer. So, next one we have to consider is, characteristics of sinusoid and complex function we will see in next thing. So, let us consider again another problem. Find that they have asked. You can find, wait a minute. So, they have given one another problem. Find the current through the circuit shown in figure. So, this problem, example 11, we will see. So, you can find the for total current is V by R. What is R? The reduction of these resistances. How we will reduce? We have to consider whether they are in series or parallel. So, whether they are in series or parallel, we have to consider. In this case, 4 ohm and 6 ohm are in parallel. So, we have to use the formula R1 R2 by R1 plus R2. So, 4 into 5, that is, so we have they have asking current through the total circuit. So, we have solved in other way, that is 230 by 4. That is there, because for 230 volt and 4 ohm are in parallel. So, 230 by 4, 57.5 ampere. Next one, current through 5 ohm, that is 230 by 5, 46 ampere. Just add these two things, you will get total current as 103.5 ampere. Then next problem, let us consider the 12th problem, right? Consider 12th problem. The 12th problem is we have to consider the equivalent resistance of 4 resistance joined in parallel are 30 ohm. They have given a figure. The current flowing through them is 0.5 ampere, 0.4 ampere, 0.6 ampere, 0.1 ampere. Find the value of each resistor bus that they have given like that. So, we have to consider each value of the resistor. So, let us consider total current now, right? Let us consider total current. The total current is nothing but now consider how the resistors are connected. They have given us parallel. So, total current is sum of all current, 0.5 plus 0.6 plus 0.4 plus 0.6 plus 0.1. So, the answer is 1.6 ampere. Now, they are giving total, we have found total current is 1.6 ampere and they have given total resistance is 30 ohm. So voltage is V is equal to I into R. So 30 into 1.6, the answer is 48 volt, right? The answer is 48 volt. So voltage across the network is 48 volt. Now we have to consider the current flowing through each resistor. One is current through, what to say, the current through the resistance of each one. So current through first resistor is 0.5 ampere. So 48 volt is across it. So 48 by 0.5, 96 ohm. The second one, 48 volt is across 0.4 ampere. So 48 by 0.4, 120 ohm. Next, 48 is across 0.6 ampere. So 48 by zero point 0.8, 80 ohm. Likewise, 48 by zero point 0.1, 480 ohms is the answer. So this is the thing. We will see the AC characteristics in next video. Thank you so much. Thank you.